Okay. Welcome everyone to Cloud Data Driven Online User Group Meeting. Who am I? I am Jean-Joseph, currently working as a data engineer. I've been in IT for over 18 years. I am currently located in New Jersey, originally from Haiti, and I am your host for today. The rules are, you guys are free to comment. There must be no offensive comments. Please keep your video and microphone off. And I have your chat disabled, so this way you guys can interact with the speaker. Also follow us on our social media. We do have our hash, which is Cloud Data.
Not sure about the rest of the audience, John, but you froze there for a moment.
On LinkedIn. Okay.
Frozen again.
YouTube, me,
Yeah, the voice is breaking.
Specialized in big data solutions.
If only the chat was enabled, we could tell him. John, can you hear us? What a great start. It's gone all together. I guess I'll just take over and start presenting, shall I? Somebody give me a yeah, Paul, go for it. We're really enthusiastic. We can't wait.
Of course.
Good. Excellent. I'll provide the enthusiasm then, everybody. It's okay. I've got this. I'll share my screen then, because obviously who knows where our host's gone. But as our host, of course, kindly said, welcome to Cloud Data Driven. And hopefully this evening, this afternoon, this morning, wherever you may be in the world.
I think I'm back, Paul, if you don't mind. Sorry about that, guys. Yep. So let me finish. Let me quickly share my screen. I'm sorry, guys. Yep. For today's presentation, we do have Paul Andrew. He's gonna talk about how can you create a metadata-driven processing framework using Azure Integration Pipeline. He is working as group manager and analytic architect specialized in big data solutions on the Microsoft Azure platform. We do have tons of other sessions lined up. The next two are these two ones. For example, we have Marcus that will talk me about scale your Power BI reporting with data flow. And then the second one is your performance tuning checklist. We will have Monica for that. If you guys want to present any session, feel free to email me at jean.joseph@bigdatadriven.org. I think that's it we have for now. Thank you so much, Andrew, for being here. It is an honor to have you. Feel free to share your screen and start with your presentation.
Thank you. We had a bit of a false start there. We'll try again. Okay, everybody. Can you see my screen, John?
Yes, I can see it.
Awesome. Let's kick off then. So yes, my name is Paul Andrew. Andrew Paul is also acceptable. Everybody does that. So as John has kindly said, we are here this morning to talk about creating a metadata-driven processing framework for Azure integration pipelines. Now, once upon a time, the title here read that this was for Azure Data Factory. And of course, this framework, this solution, these things that I want to talk to you about were originally born in Data Factory. But as things progress with the mighty Microsoft product groups, we now have a different flavor of this as well. So when I talk about Data Factory in this presentation, now, given how things have moved on, we can very much think of Data Factory and Synapse integration pipelines as completely interchangeable with everything that I'm going to show you and everything that we're going to talk about. So this orchestration, this control flow plane that we're going to look at, it could exist in Data Factory, it could exist in Synapse. We don't mind, but as this solution was born in Data Factory, a lot of the content I'm going to show you is Data Factory orientated, but interchangeable. So if you would like to grab a copy of the slides that I'm about to show you, do feel free. Go to my GitHub and the community events repository. There's a subfolder in there called Cloud Data Driven, so you can grab a PDF of these if you already want them. You want to look ahead at the exciting things that I'm about to show you, then please do, and I'll share this again at the end. So let's just have a really quick introduction to Data Factory for those that have never used it before. And when I say really quick, I'm literally talking 2 slides. That's how quick this intro will be. So if we think about some data as data engineers, data professionals, and that data that we want to get from A to B to C, whatever that may be, whatever data, whatever computes that we're going to use to do that, and we think about Data Factory sitting there as the orchestrator to this thing that we're trying to do, to this data processing operation. And what we can do within our Data Factory is we can define pipelines. And those pipelines can be packages of work, if you like, that will wrap up that processing activity, whatever it is that we want to do. And Data Factory will then handle the management of it, the scheduling, the monitoring of that pipeline. And that pipeline, as I say, is that package of work, a logical package of work, if you like. And for those that are fans of SQL Server integration services, I absolutely am a fan, or was a fan. And we can think of a pipeline, if you like, as an SSIS package. You know, that same sort of comparison is fine. It's okay to think of that. One's, of course, a cloud native orchestrator. One's a package of work that we run on a SQL Server instance. The components that go into our Data Factory, they're all JSON. So if Data Factory is our orchestrator, its hymn sheet is JSON. And there's 5 components that we'll need to build, configure, and create to get our Data Factory pipelines running. The first one will be link services. So this, again, comparisons to sys packages will be very much like the sys connection manager. We need something within our Data Factory that will connect to a service, you know, storage or compute or whatever, and that link service will contain the information about that connection, the authentication details, whatever they may be. So we'll start with those link services that we need to create. Then within our Data Factory, we can create this thing called a data set. Now, this isn't necessarily the data itself that we want to interact with. It's just a metadata representation of the thing that we're going to use. So if it's a Parquet file in our data lake, that data set will contain information about the file path, the file name, the format of that file, you know, its schema, the data types, etc., etc. Now, these data sets, they can be very flexible and we can reuse them. We can keep them very generic, but typically we need a data set that will authenticate using our link services to then do something. Moving on to number 3, this idea of an activity. So within our Data Factory pipelines, we will add activities to our developer canvas, and it's those activities that will contain information specific to the service that we want to work with. So if that's a Databricks notebook, to my icon that I've got on screen here, if that second pipeline is we want it to run a Databricks notebook, we will have an activity applicable to that. And that activity, like with our data sets and things, they will have information specific to what that activity is going to do. So the workspace where that notebook might be, the parameters that we want to pass to it, those sorts of things. We can have different types of activities, internal and external, but that's perhaps for another deep dive session maybe in the future. Then lastly, number 4, these pipelines that I've already talked about, these logical groupings of work. Pipelines can be chained together. We can call one pipeline from another, and those pipelines will wrap up those activities. The activities may have input and output data sets. Both may authenticate with our link services. So you kind of get the idea of this hierarchy of components that we need within our data factory. And then lastly, number 5, triggers. So we want some mechanism to actually execute our pipeline. Now a trigger, like our SQL Server agents, again, if we want to do some comparisons, will attach to one pipeline or attach to many. And those triggers can be scheduled in very much an iterative way that will happen daily, weekly, monthly, whatever we like. We can have event-based triggers that will perhaps subscribe to a file creation event in our blob storage that can then cause a pipeline to go and run. We can do things like tumbling windows, and we could do lots of things, but we'll need that trigger to actually get our pipeline to run, unless we're going to do it manually or we're going to invoke it from some other programmatic way. So those are our 5 components of our data factory, if you've never used it before, and how they kind of wrap up and how you might build them out to create some process. Now, the first 4 of those components, what you'll find is in the developer portal, when you're interacting with your data factory, you'll find that where you've got a user interface that represents that underlying JSON, you'll find a little box like I've got on screen here that will say add dynamic content. Now that means that we can inject into that JSON like you would for, say, an ARM template, and injecting into that JSON means that we can then dynamically influence what those first 4 components of our data factory are going to do. So with that, we can then be very flexible in what we want data factory to do. We can be very generic with those components that we define. Okay. So that's the quick introduction to Data Factory. It's very light touch. Hopefully you're all seasoned Data Factory people. So let's move on to kind of the meat of what we want to talk about today. So I'm going to give you a problem then, given what we know about our Data Factory or our Synapse pipeline. The problem statement I'm going to say to you is, well, how should we structure our pipelines? They could exist in lots of Azure regions. We could have pipelines for ingestion or extraction, pipelines that transform our data, pipelines that control parts of our Azure environment, scaling up and down services. We can have pipelines that do anything. We can have lots of activities within those pipelines. So as a sort of very broad problem, how do we structure them? So I've obviously got some pipelines lined up here. We can use the new industry standard that I'm trying to enforce of the Pipelinosaurus Rex. So we could structure our pipelines to look like a dinosaur, but don't do that in your customer's documentation. They don't like that. Anyway, this is where an online event doesn't work, because I know you're all laughing now and think, Paul, you're an idiot. And like, yes, that's true, but I don't know that, so I'm just going to assume. Anyway, let's elaborate on that problem then. So I've said, yes, how do we structure our pipelines? And in my slide where I talked about Data Factory and what it did, I had a very sort of generic A to B to C movement or process of some data. Let's elaborate on that and think about it in the context of this problem. So we have a data lake store. We have some layers within that storage or within that platform. I've called them landing, clean, transform, served, whatever you want. It doesn't matter. I don't really mind here at this point. And we may have Data Factory. Now, let's say that we have 3 business processes or 3 data sets that we want to move through this platform to transform it, to enrich it, to do whatever we want to ultimately get insight from that data. So we create 3 pipelines, 3 business processes, 3 pipelines, makes sense. And for each of those layers that we take our data through, we're going to have some activities to copy it. We might call a notebook to transform it. We might have an Azure function, as I very descriptively called do stuff. And we could say that for those 3 business processes, we're going to execute them in these horizontal processing planes. So each pipeline will contain all 3 activities chained together. We could run all of these pipelines in parallel, and we would get the outcome of that for those 3 business processes. But let's say one day we encounter that we actually have a dependency between some of those activities or those data sets that we're enriching through this platform. So to handle that, we can't use that horizontal processing model anymore because we have this interdependency. We need to do something about it. So say, fine, instead of pipelines 1, 2, 3, I'm going to create pipelines A, B, and C. And then instead of a horizontal processing model, I'm going to go with a vertical processing model. So I'm going to process all of the activities to get me from landing to cleaned. And then I'm going to do all of the ones that get me from cleaned to transformed and so on. So, that dependency problem then goes away because we know that we've processed everything in that vertical plane first before we move on. We're fine. Guess what? We end up with another dependency, maybe between our number 1B data set and our number 3B data set. So as before, that vertical processing model no longer works. We have a dependency there. Perfectly normal. We have early arriving facts or late arriving dimensions, whatever you want to call them. So we need to do something about it as part of our orchestration. So we say, fine, I'm going to go really granular with how I actually construct my pipelines. I've got 9 activities. I'm going to have 1 pipeline per activity. Okay. And then what we can do is we can chain everything together. We can execute those pipelines one after another. We can adhere to that dependency that we have, or those 2 dependencies, 3 dependencies, and we can then create a wrapper for this, a bootstrap, if you like. And that bootstrap, that green pipeline that I've got on screen, we can then use that. We can have activities in there that call all of these things. Now, I'm talking about 3 business processes and 4 layers that we want to move this data through, hypothetically. So that's 9 activities potentially that I'm going to have that need to go into my parent pipeline. And this is only a very simple example. This could obviously get a lot more complicated when you start adding logging and auditing and whatever else. So what you'll find within Data Factory at the moment, you'll then hit this limitation whereby you can only have 40 activities per pipeline. So that's a problem. This certainly doesn't scale when we get to like an enterprise customer that's got hundreds of data sets. So you think, okay, well, what I'm going to do then is I'm going to refactor my pipelines. I'm going to go really granular where I need to, where I have those interdependencies. But then where I don't, and I can group things together, I'll come up with, this sort of different grouping of activities where things can run in parallel that don't have an interdependency. So we say that we have a working model of a grandparent, which is the overall bootstrap, a parent where we consolidate that work because we don't have dependencies, and then child pipelines where we do, so we can go much lower and we can have that granularity. But this still isn't scalable. This still is we're going to hit limitations. It's going to be difficult to manage, difficult to deploy. You're just going to end up with spaghetti, a rat's nest of activities and pipelines within your data factory. So maybe as a proof of concept, but certainly not when we're talking about delivering something for an enterprise in production. So that problem, hopefully I've elaborated on it. We're all on board as a baseline here. So let's move on and think about the solution. So the theoretical solution that I want to put forward to you is very simple, that we use metadata to drive our data factory pipelines. Now, I'm not going to claim to have reinvented the wheel here, certainly not. Using metadata to drive what we're doing is not a new concept. You know, people have been doing it for years and years. Frameworks around SSIS packages and things like that, and running stored procedures in SQL Server or whatever the technology may be. Again, there's nothing new here in terms of a concept. It's just how do we actually apply it in our Azure environment for Data Factory in this case, or for Synapse. So let's use some metadata. So let's just explore this solution again, very theoretical. So for that metadata, I'm going to use SQL Server, and then I can control which pipelines I want to call when. So if we kind of revisit that problem structure that we had before, where we had these 9 activities, and now we bring in that metadata, and we say, yes, I'm going to go granular with them, with those pipelines. I'm going to have, you know, the smallest package of work represented as a pipeline, and I'm going to call it a worker pipeline. So we have 9 worker pipelines here, spread across 3 stages of execution, potentially thinking about those vertical planes. So in our metadata, we say, I've got 3 execution stages in one table. We have pipelines in the other table. So we represent that vertical processing and that horizontal processing in 2 tables. And then you can do something really cool in a SQL Server database. You can join 2 tables together. Okay, exciting, right? Advanced. So we join those tables together, and we say that actually for processing stage number 1, I want to execute pipelines A, B, and C. For processing stage number 2, we execute D and E, and, you know, and you get the idea. So a very sort of theoretical way of actually executing these workers, very simplistic. I don't mean to be overly offensive with the simplicity of my example here, but, you know, we can build on that. However, there is one more problem. You think, Paul, yes, this sounds great, but there is one more problem. And that is the execute pipeline activity that we have within Data Factory does not support dynamic content. So we cannot inject into that execute pipeline activity and say from our metadata, we want to then go and call this worker instead. Okay, so what do we do? Well, within our solution, we have our Data Factory, we have our SQL database in this case. We need to think about another service that's going to act as the middleware when it comes to handling that execution. Now, option 1 could be to actually use the Azure Management API, and we can use a web activity. We can hit that Management API, we can authenticate, and we can say, call this worker. It could be in the same Data Factory, it could be in another Data Factory, and yeah, we can carry on. So that's one approach to deal with it. Another approach could be to use logic apps. Similar sort of idea. We'll use a web activity, but we'll call the logic app's URL, and then within your logic app, you can have an action that could call back to a Data Factory pipeline if you wish. Yeah, okay, fine, that would work. Option 2. Or option 3, which is my preference, would be to use an Azure function. So we can have the activity within our parent pipeline that will call an Azure function. We can give it some information. We can then tell our worker to go and execute. So to flesh out that solution, you know, in its entirety, what we need to say is that we need to use metadata to drive our Data Factory pipelines, and we also perhaps need functions to handle that worker pipeline execution, just because we don't natively have that capability available within our Data Factory. Okay. Any questions at that point? I'll just take a pause. Stunned silence.
You guys do have access to unmute yourself. Feel free to unmute if you have any questions.
Going once, going twice. Okay, we'll move on. Silence means, Paul, this is great. Just carry on. I'm loving it. You all subscribe to that. Again, virtual audience. Oh, it's a killer. So, given that problem statement, given that solution, very sort of theoretical, this is where I now want to introduce you to the processing framework that I've created and put out there to deliver on this. So I won't bore you with this slide, but because we've created this framework, we now get lots of other features and things that we can do in here. So we have that framework not just to control our pipelines, but we can handle parallel executions. We can have logging and reporting. We can have email alerting, all of those things that any good framework should give you, not just its simple functionality of wrapping up the orchestration. So let me introduce you to the various parts of it, and let's start with the metadata database, because we're data people. If you've looked at the database and you understand the database, then everything makes sense because it's data. And here is the metadata database flattened out as a diagram and a representation for you that I just want to talk you through the tables in here and what they do and I guess why. So the core to it, hopefully as you've gathered from the slides I showed you earlier, will be that pipelines table. Excuse me. That pipelines table is going to contain that key information about those worker pipelines that we want to go and execute as part of our framework. So that pipelines table, as you'll see at the center for good reason, lots of relationships to all the other things. Around that pipelines table, drawn very deliberately here, we have lots of other tables that will handle that execution process. So we have things like those pipeline dependencies that we'll need to perhaps know about as our processing runs. We have the stages table, again, based on what I showed you in the earlier slides, that will deal with that separation of those execution stages or those vertical processing planes as I described them. Above those execution stages, if you want to go sort of at a high level, there's also this concept of an execution batch. So if you want to run this pipeline multiple times at different frequencies, say an hourly execution cadence and a daily execution cadence, you can put this into the metadata. You say run this framework for that day processing and whatever metadata pipelines that represents, the same for hourly, and those batches of execution can operate concurrently to each other. So two batches of this framework can run at the same time or more, depending on the limits of your data factory. The next set of tables, just to call out, will be to do with the location and the authentication of those pipelines that we're going to call. So this framework has the capability to reach across different data factories, different resource groups, different subscriptions, and even different Azure tenants. So when I showed you that sort of global map of where our pipelines are and how they're structured, there is no boundaries here in terms of the Azure environment. If there's a data factory out there that you can hit, you can authenticate against it, then this framework can call those pipelines in there. Okay. And service principal information is what the key to that authentication. We can also, if we wish, separate out that authentication at the lowest level. So you could, if you wish, have a separate service principal for every single pipeline that you want to go and call, and the metadata will support that for you. The top tables relate to email alerting, as a nice sort of side feature of the framework. If you want that, you can say for a given pipeline status, I want to subscribe to those alerts. So, you can create that metadata for that, for multiple outcomes, multiple recipients, however you want to configure it. You can get email alerts as part of the execution. Then the tables to the right-hand side are all of the ones without any relationships between them, These all relate to the actual running and the logging of the pipelines as they execute. As you trigger the framework to run, we will have these discrete tables that deal with that execution. And it's the current execution table that will have everything in it that's happening now. A table on its own to keep it small so it doesn't impact performance, and then a long-term execution log of everything after you've had a completion, successful or otherwise. Then lastly, the table in the middle, the properties table. Configuration information about how we want the framework to behave. Do we want to override restarts? How do we want to handle our dependency chain? Do we want to have email alerting turned on? So all those bits and pieces that you want to configure and customize in your environment will go into that properties table. That's the database. Next up, let's just look at the Azure Functions. So I'm a big fan of Azure Functions. I think they're great. In my case, I will develop an Azure function using C#. I'll probably use the .NET Core 3.1 framework. There's no reason not to. All the libraries and classes and things are in there that I need, so that's fine. Either in Visual Studio or VS Code, again, your preference. And when we deploy that, we will ultimately need, if we're doing C#, a .NET host to act as the runtime, and the app service plan can be premium or whatever you wish, but a consumption tier is good enough for the framework for the most part, depending on how many times you're going to execute it, of course, but you don't need that dedicated compute is what I'm saying to you, that middleware function, it's very lightweight, it's very fire and forget. There's no long running processes in those functions. When it comes to the framework hitting them though, of course, we will have our link service, we will have that first class citizen activity that will hit the function, and we can carry on. We can, of course, use Key Vault to handle the authentication, both for the function app itself, or, if you want to, again, go granular with your security model, have keys for each function, or if you want, we can use, of course, managed identities now. And the framework will support all of these things. So, it's just a bit of extra configuration depending on how you want it to operate in your environment. In either case, those functions will interact with those worker pipelines and deal with whatever that downstream process is. So the Azure Functions app that you'll need to deploy if you do this, what you'll find in there is 5 different Azure functions and how they relate and hopefully what they do. I went for an original naming convention here of calling something by what it does. I know that's not very typical in a lot of places now. We have to come up with really obscure naming conventions, but hey ho. So validating the pipeline is just checking that worker exists, executing it, self-explanatory. It's going to go and call it, pass the parameters that we want to accompany that pipeline at execution time if you wish. If the pipeline has indeed completed or failed or whatever, we'll have a function that will go and check what that status of it is, and we'll have a function to handle the errors if a failure has indeed occurred, and it will get those error messages for the activities within that failed pipeline. Now, all of these follow the same approach. They all will handle and call that downstream worker pipeline. Again, I've got Data Factory icons on my screen. These could be Synapse icons. You could have one Synapse icon, one Data Factory icon. It really doesn't matter. The functions within them, with help from my friend Richard Swinbank, he separated out the internals of those .NET classes, and we now have a service, if you like, for a pipeline execution. And it will be passed off to either a Synapse client or a Data Factory client. The last one, the send email, self-explanatory, will hit your Office 365 subscription or whatever. So was there a question? I can hear somebody. No? Okay. And yeah, that email will get sent with appropriate details of that worker that you subscribe to. So those are the functions. I think then the last thing is really just to talk about the pipelines themselves, and then we can actually jump into a demo and see them in action. So for the pipelines that I've got now, in my earlier slides when we were about being very sort of theoretical about this, I said, yeah, we could have a grandparent, a parent, a child, or whatever. The actual working definition now and the roles that I've created for what I'm calling this pipeline hierarchy, just the same way that we had a sys package hierarchy, I'm going to say that at the top level, we have a grandparent. Now, this grandparent, the role is maybe a bit fluffy, but I'm going to say at this level, it's optional, which seems a bit odd, but I kind of included it for completeness in this hierarchy. Because at that grandparent level, we could think about doing other things to our environment before we call the framework. Excuse me, if you think about the batch execution model, we might want to trigger multiple instances of the framework simultaneously, in which case you might want to wrap that up as a grandparent process. So the grandparent there is kind of really for platform setup and flexibility and whatever else you want to do. Use it or don't use it, I don't mind, but it's there for completeness to allude to the art of the possible. Then at the parent level, we have the execution wrapper for the framework. So at the parent level, we could pass in a batch execution name if we're using that, or we say to it, just go and run. I don't care about batch executions. And then that parent will kick off all the necessary bits and pieces to interact with that metadata and to actually start iterating through those execution stages. As part of that parent, we will have the child that will then be called, and those child pipelines will scale out. So if within that single stage execution, we've got multiple workers that can run in parallel, we will scale out there. We will use Data Factory's default behavior for each activity, and we will run those child pipelines in parallel where we can. At the infant level, that will be called by the child. So for every worker, we will say, give me an infant, and it'll be that infant that is responsible for the validation, the execution, the monitoring, and reporting the outcome of that worker. So for every worker, we'll have an infant that sits above it looking after it. And perhaps the amusing thing here is that if we talk about a grandparent, parent, child, and infant, the infant does the most work, the child does the least amount of work, the parent sits there looking after it, and the grandparent kind of pokes you with a stick if you've done. So hopefully that's kind of true in real life as well, right? The infant does all the work. And of course, lastly, for completeness, my definition of a worker pipeline. So a worker pipeline is outside the remit of the framework in terms of it being built and delivered for you, but that worker will handle whatever it is that you want to do as part of your platform. It's for you to go and build the worker and tell the framework it exists and to go and call it. So let's take a look at the activity chain. Now, this is obviously impossible to see on a slide. It's far too small. So I've just put it on here for reference, but then let's just go and have a look at the Visio diagram for it instead. So let me bring up, Visio. Oh, I thought I had it open. Guess not. 1 second. The link to the Visio diagram was, of course, in the slides as well there for you if you want to have a look at it. In the docs in here. Come on, Visio. It's loading on the other screen. I'll move it over in a sec. Oh, Visio's not responding. Oh dear, it's all going downhill. Any questions while we wait for Visio to respond on my computer?
I have a quick question, if you don't mind.
Yeah, go ahead.
Does this framework work also with mapping data flows or Power Query built into ADF, or is it specific to the built-in ADF features?
I would say the way I'd answer it is that the framework handles the control flow within your data factory. Now, if you have a worker pipeline that's got a mapping data flow in it, or a Power Query execution, or whatever activities you want to use, go ahead and create that in the same way that you would develop it otherwise. And once you've got that worker pipeline, then just go and tell the framework about it. So the framework doesn't really care what's in that worker, whether it be a mapping data flow or otherwise.
Okay, thanks.
Yeah, so it's that separation of like the control flow plane, as I would call it, and that data flow plane. And I take the same comparison with SSIS packages. You have a sys package control flow, you have a sys package data flow.
Paul,
Okay.
one question from my side, a quick question.
Yeah, go ahead.
Yeah, so does this framework also supports, capturing the records which are getting ingested in different layers?
Capturing the different records that are ingested in different layers. I'm going to go with no, not unless you want it to. Again, that same sort of distinction between this framework isn't to do data transformation. This framework is to orchestrate your platform. Now, if you want a pipeline to capture your dataset rows, a row count or something like that as part of the copy activity's output, then absolutely build that in and pass it as a parameter, and the framework can look after it for you. So depend on your use case, but that same sort of separation. This framework isn't for data transformation. Maybe let me be clear about that.
Okay, got it. Thanks.
So hopefully you can all see Visio now, correct? Yes, no?
Yes, we can see it very clearly.
Awesome, thank you. So what I've done here is I've flattened out all of the activities that go into the various layers of this framework, just so we can try and understand them in a bit more of a human readable way. Because certainly when you're looking at the Data Factory portal and you're clicking through your pipelines and within a for each activity and an if activity, and the breadcrumb and the process for understanding it isn't that great. So I flattened it out. I even created my own Visio stencils to actually go and do this. So again, something you can go and get from my GitHub repo if you want. So anyway, within here, we've got that grandparent level. You'll see that I've labeled things kind of as I described, environment setup if you wish, but then we have this framework bootstrap, and we get into this parent level. So at the parent level, we will start, and the first thing the parent will do is to check if it's already running, which you think, oh, that's a bit obvious, but we don't, of course, want to incur failures, and we don't want to repeat things if the framework is already running. This is also batch execution aware, so you can concurrently run the framework, but not if that batch is already running, or if there's already an instance of the framework running. So Data Factory will go and hit itself and say, is a parent pipeline already running? If it's not, then fine, we can carry on. Kind of a subtle, but I think quite an important feature, because especially when we're remote working, we can have people on opposite sides of the world that both go and trigger a pipeline. They don't necessarily know what each other's doing at a given moment. So the framework kind of looks after that human element, or tries to. So once we've done that, we will set up our metadata. We'll do some integrity checks. We will check if a previous execution's occurred. Do we need to clean up and restart here? If a previous execution did occur, and maybe there was some wider platform failure, then the framework will go and deal with that for you. It will look at those pipelines and say, what was the actual outcome? If you've perhaps got a framework where the metadata has become disconnected from what Data Factory did. Fairly unlikely, but I have had it happen, so I built in the functionality to handle it. Then moving on, we have an execution wrapper where we'll get all of that metadata from those tables. We will bring it into our current execution table, and we will tell the framework to start processing. And that first set of metadata will be that stage information. So give me a distinct list of all those execution stages that you want to run. Then pass those as an array to our first for each activity. Now at this level in the parent, the for each activity is going to be running sequentially. So because of those vertical processing boundaries, we want that vertical processing separation. So let's start with stage one. We kick off and we say execute stage one. So then we break out into the child, and the child is here just to give us that scale out capability. So we say for stage one, go and get me all of the worker pipelines that are applicable to stage one. That could be 50 pipelines, it could be 100, whatever. So we return that list of pipelines that we want to execute in stage one, and we hit our second for each activity. So we're nesting the for each activities here. This one will run in parallel. So the default is 20 parallel threads. We can go to a maximum of 50. I'm fairly sure in the framework I set it to 50 by default, just to kind of give us that bandwidth. At the moment it's limited to 50, but maybe Microsoft will give us some more juice in the future. Now, once we've done that, say we're executing 50 pipelines in parallel at this point, we then hit the worker executor. And it's this worker executor that will then bring us into the infant. So at the infant level, we're getting details about that worker. We're saying, what is the tenant that it exists on? What's the subscription? Give me some service principal details, or go and get them from Key Vault to actually allow that worker to run. We will say, what are the parameters for it, etc., etc. And we'll take this forward and we'll say, fine, we have all the information about this worker, go and execute it. So we will then go and hit the data factory where that worker pipeline lives. It could be the same data factory as where our framework is, but it could also be separate. We execute it, and it's very much an asynchronous process here. We execute, we fire, and we forget, and we get back the run ID from that execution. So once we have that run ID, we will then wait as part of an until activity, and we will keep checking until that worker pipeline has completed. Once it has completed, we will report the status, whether it be failed, success, whatever, and we will pass off that status. We will update our metadata. Maybe we'll send some email alerts if they're configured, and we'll move on. Whoops, zoomed out too much. So that infant has handled that end-to-end process of calling that worker. That infant could have been called in parallel by our child for lots of different workers. So let's pretend we're bubbling back up through the layers. We've done all of those parallel executions that were called by our child. We then move on to the next stage of execution, and we do the same again. After we've done all those execution stages, the parent's happy, we've finished, we report the overall outcome, we do a few final checks, and the framework is complete, and we archive off that execution log. Sorry, I keep zooming out too much again. Alongside the sort of core pipelines, there's a few workers that I've got of my own for throwing exceptions and checking the pipelines running, and we've got a separate utilities pipeline to send an email, which you could use for lots of other things as well if you wish. So that's kind of a tour of the framework, and hopefully you've kind of understood from the metadata what's going on. So now let's take a look at it. And for that, I'm going to use my friend Management Studio, and let me just reshare the screen for you. And let's get the Azure portal up. So within the Azure portal, I'm just conscious of where my microphone is now because I'm looking to the side at my other monitor. So within my Azure portal, I've got my data factory, I've got the processing framework up here, and I've got the parent pipeline ready to go. And then in the metadata in my SQL database, I've got my current execution table empty at the moment because I've not done anything, but we have pipelines in here that are configured, and we have execution stages configured. You know, we've got a set of workers that exist alongside the framework data factory. Now, these workers are really, really simple. So I have a worker pipeline just with a wait activity. The wait duration is parameterized. So these are fake workers or dummy worker pipelines, if you like. That I've got 10 of them that I can just call as part of the framework just to show this thing happening. So what I'll do is I'm just going to trigger my parent pipeline. What you'll probably notice is that in Data Factory, if you run in debug mode and you have an execute pipeline activity in there, then in debug mode, that for each activity won't be parallelized. It will run sequentially and you won't have a choice about that. So I'm triggering it because I do want it to go parallel. So what I can then do is I can look at the monitoring pane. Lots of green ticks here where my demo worked earlier when I tried it. So let's hope for some more green ticks. But you'll see that parent kick off. You'll see it start going through the motions of what I described. So we can switch to the database table. And what we'll see hopefully in here once those activities kick off is the metadata will come through. So we've got 15 pipelines that we're going to go and run. We're calling a couple of them twice. We've got them in different execution stages or repeated execution stages. It doesn't matter. Another advantage to the framework is if we have a very generic pipeline to ingest our data, we can call it multiple times and pass in different parameters. So let's hit refresh a couple of times on this. So you'll see that we have the status of preparing. We've got a status now of validating. I'll keep hitting refresh because that'll make it go faster. Any questions while we're kind of just watching this run?
Yes, I do have a question.
Go ahead.
All that metadata that's in your database, how do you maintain it? Just by writing some T-SQL statements, or do you have some application to update it?
I'll go with the consultant's answer of it depends. Controlling metadata and controlling data within any database that's a broader question, right? It's not applicable to this solution. We've all faced that problem, but yeah, what you'll see in my GitHub project for this solution, I've got a set of sort of idempotent scripts that will run at the end of the backpack deployment that will handle and populate that metadata. There's a set of stored procedures in here that will populate those tables for me. So I'm cheating a little bit, but I would say it really depends on how you want to manage your own database. It doesn't have to be metadata, of course. It could be any data that exists in your data warehouse that you want to handle at deployment time. So what you'll see in here very deliberately is you'll see a failure. So my intentional error pipeline, guess what that does, has failed. And what the framework has done is it's looked ahead and said that, well, okay, for that intentional error in execution stage number 1, I'm now going to look ahead and actually I'm going to block those worker pipelines in stage 2 because I know that there's a dependency there. And if I switch back to the portal, we'll see the same occurring if I go to the monitoring. So we'll see the intentional error pipeline has failed. We'll see a bunch of infant pipelines. Let's zoom in a touch. A bunch of infant pipelines that are accompanying each of those workers. Because I'm actually working within a single data factory, you'll see those workers executing alongside the infants as well. So like with our Management Studio, let's hit refresh multiple times, it'll make it go faster. I prefer to look at it in Management Studio actually. So success, success, success. I tried to create a very sort of demo friendly execution for you. So that until activity that executes within the infant, there's a configuration, there's a property that says, you know, how quickly do you want the until activity to wait between iterations or between checks of your worker. So for this demo, I set it to 5 seconds. So, you know, I want it to check very quickly. You know, it depends on the concurrency limitations, of course, of your data factory as well. But, you know, if you're calling a Databricks notebook that's running on a job cluster, you might need to wait for that job cluster to spin up and lots of things are happening. So, you know, a 1 minute iteration or a 5 minute iteration might make more sense for your execution. But it's there in the properties table if you want to control the configuration of it. You'll see that, again, to try and keep things demo friendly, the parameters that I'm passing or the values that are used for this, those wait durations, they're all very small. So I'm trying to do this as quickly as possible. The main reason for that is because I want to just show you the restart capability and how it will just clean up and handle that failed pipeline. So we're just running what we're running now. We're running execution stage number 2 still, but again we've looked ahead, so we know that we've got blocked pipelines in stage 2. So the framework has looked ahead and it's actually blocked pipelines in stage 3 as well.
I have a question, Paul. Shall I ask you now?
Sure.
So actually, so for example, if we have 3 stages, stage 1, 2, and 3. So if we are seeing any failure at stage 1, so it will not block at stage 2. Like once the stage 1 is completed, that means so successful. And after that, stage 2 will stop. So this framework will not work in this way.
Sorry, your audio isn't very clear. I didn't quite understand that. If you execute stage 1, then stage 2?
Yeah, for this current execution, the stage 1, we have seen the failure. So even if we see the failure, the stage 2 started. So in that case, once the stage 1 is completed with the success message, so if there is any failure at the stage 1, so is it the framework will not stop at stage 2?
It has started stage 2. Again, it's a configuration option. So if you have a look in the documentation, there's different failure handling capabilities that you can configure. You can say, use the pipeline dependency chain that you know about, and in which case the pipelines will carry on, excuse me, and it will complete everything that's available. Or it will just block everything and say, you know, I've got a failure, I'm just not going to do anything else. Sorry, my throat's drying up. Or we can actually just say, carry on, just run everything, I don't care. So in my case, I've got it configured to use the dependency chain, which will use the pipeline dependencies table to look ahead and know what's going to be called. Hopefully that answers your question.
Yes.
Great. So the framework has hopefully completed. We've got some blockages. We've got a failure that occurred in execution stage number 1. Now let's pretend that I'm a good developer and I've gone and fixed that problem in that worker. Once things have just finished in here, let's just filter out all those successors, filter them out, not include them. Oh, so the child is just finishing up, so probably stage 4 of the child. Yeah, stage 4. Come on, Data Factory, finish off what you're playing at. So we can see from the metadata, all of the workers are returned. We're just waiting for that bubble up of the layers. Interesting. So we know stage 4 is blocked. Why is this activity taking so long to run? Because that lookup activity isn't actually going to return anything because there's no pipelines in that execution stage. It's taking a really long time for the database actually just to return, isn't it? What is this database doing? Very, very little. You'll notice that my database is actually only set as a standard S2 database here using 50 DTUs. So very lightweight. I did some performance testing and concurrency testing with 300 and 600 worker pipelines just to sort of see the limitations of it. And I actually hit the concurrency limitations within Data Factory before I actually stressed the database. So there we go, finally. God, 2 minutes just to return no results from a lookup activity. That's not very good, is it? not my fault. Anyway, yes, intentional error. My parent pipeline has failed. All good. So now in my execution, nothing really to report. So what I can actually do is, if I wish, let's pretend I fixed it, I can just rerun that parent pipeline. That parent pipeline will, of course, do what it needs to do in Data Factory. It'll check it's running. But then what will happen after that is that it will just clean up that metadata. It will look for that failure. It'll say, okay, I've got all of these successors. Where that failure occurred, we'll retry that one and we'll unblock those other pipelines, and then we'll move forward. Now, again, this is configurable in the properties table. So if you don't want to do that and you just want to say restart my processing regardless, you can do that. If you want to do something else, maybe you just want to truncate the table and start again. The framework doesn't mind. It will deal with that. All you need to do is just trigger the parent pipeline again. There's no sort of thinking involved. It's down to the metadata to decide what it does. Let's just see what's happening in the Azure portal with that parent. So we've checked it's not running. We're just doing that execution precursor. Last sort of bits and pieces just to kind of illustrate to you what's happening. That failure status is still there. What I'll call out for you just while we're waiting is that you can, of course, grab the code for this in my GitHub repo for the proc framework. What you'll also find is, not to blow my own trumpet, but I think there's some good documentation in here that myself and others have contributed to for the framework about what it is, why use it. That failure handling behavior that I talked about, if you want to dig into it, I did write a page for it. Where did I write a page for it? Failure handling and cancelling pipelines. So yeah, there's different behaviors there that you can configure as part of this if you want to, and where those blockages occur. The framework will even handle it if you want to cancel the worker yourself. It'll report back that cancelled status and it will handle that too. Last refresh. Oh, come on. God, my Data Factory's been really slow just because I want to show you. What are you doing, Data Factory? Oh, it should be about to do it. There we go. Definitely underwhelming given the suspense build-up, right? But basically, the takeaway was that, you know, it's the framework has left the successes in place. It's dealt with that intentional failure. It's looked ahead for those blockers, and it's just restarting basically. Now, my intentional error will intentionally succeed this time, just because I built that into the precursor store procedure. So nothing really to show, but say lots of capability here, perhaps more than I've got really time to demonstrate about cross-tenant execution and calling Synapse pipelines instead of Data Factory pipelines. It doesn't really matter. Just configure your, configure your orchestrators in the orchestrator table and use the orchestrator type to determine whether it's a Synapse pipeline or a Data Factory pipeline. So with that, demo, I guess, over for the most part, and I will just wrap up with a thank you very much for listening. Hope you enjoyed it. The details of me, my blog, my YouTube channel, etc., are on here. So thank you.
Thank you so much, Paul. It was a very great presentation. Right. If you guys have any question, feel free to unmute yourself and ask that question. Otherwise, let's wrap up for today.
So one last question, Paul. Anyway, thanks a lot. It was awesome.
Thank you.
Your Git repo will have the backup of the tables also, at least the metadata's configuration table details and all?
Yes.
Thank you so much.
That was an easy one.
Are there any other questions, guys?
Silence.
I think we are all set. So I'm going to share my screen if you don't mind, Paul.
Sure.
Thank you, Paul. It is a pleasure to have you here. And by the way, that was an amazing presentation. I learned so much from it. This session is being recorded, guys. Okay. I will share the recorded video with you guys. And then don't forget to follow us on Twitter, LinkedIn, Facebook. Also, feel free to share this user group with your peers. I will really appreciate it. Thank you all for joining. Okay. And one more time, thank you, Paul.
Thank you for having me.
Don't forget to sign up for. You two are very welcome. Bye.
Right. Thanks, everybody. Bye for now.
Thank you all. Bye-bye.
Thank you.
Thank you all.
Thank you.